Okay. All right, I would like to call to order the regular meeting of the West Basin Engineering and Operations Committee and a special meeting of the Board of Directors. With that, we have a determination of form, Mr. General Manager.
Yes, Mr. Chairman, I'll do roll call. Director Harold Williams.
Here.
Chairman Desi Alvarez.
Here.
Director Don Deere.
Here.
Director Gloria Gray. Director Scott Houston. Mr. Chairman, we have a quorum.
Thank you. So, sorry, public comment. Do you have any public comment?
Mr. Chairman, we have not received any requests for public comment, though this meeting is being held both in person and virtually. If there's any member of the public that would like to make public comment, now would be the time to do so. If you could please raise your virtual hand, we will call on you. Mr. Chairman, I do not see any requests for public comment, although there is one other thing I'd like to note. Director Gloria Gray has joined the meeting.
Welcome, Director Gray.
Thank you.
And there are no presentations. Okay,
That is correct.
so we will move to the action calendar. And the first item is the procurement of reverse osmosis membranes. Mr. General Manager, would you like to introduce the item, please?
Yes, thank you very much, Mr. Chairman. Item 5A, as you mentioned, is related to the procurement of reverse osmosis membranes. It's worth noting that West Basin's legal counsel has met with the legal counsel from Chevron just last week. I regret to inform you that there was no resolution to the matter between West Basin and Chevron. At this time, I'd like to ask that the committee postpone this item to the board meeting, which will take place on Monday. It's my understanding that the board of directors will be moving into closed session at the beginning of that meeting. At that time, legal counsel will provide the board a full update on those conversations with Chevron and West Basin. And then, of course, the board of directors could choose to hear that item at the board meeting or postpone it into the September committee meeting.
If there's no objections,
Done here.
that would be fine. Let's postpone this for next week. Then, moving on the action calendar, the next item is procurement of sludge handling welded steel tanks for the solid handling improvement project. Mr. General Manager, would you please introduce that item?
Yes, thank you very much, Mr. Chairman. This item does begin on packet page 7. And for this presentation, we do have John Benner, our engineer too.
CJ, good afternoon, Chairman Alvarez, members of the board. Today I'll be presenting an action item recommending the procurement of 2 steel sludge handling tanks on the Solids Handling System Improvements Project, which is CIP project number 10059. As CJ mentioned, item 5B begins on packet page 7. We'll be beginning today with the attachment A, the presentation, which begins on packet page 13. Slide, please. So the solids handling project is now approaching the end of the design phase. Since we onboarded the design consultant in August last year, we've completed a condition assessment verification, preliminary design report, a 60% design workshop, and we recently received the 90% design submittal. Staff reviewed that submittal around July and August, and we submitted our comments back to the engineering design consultant, and we're waiting for them to conclude the 100% design submittal, which we expect in late September or early October. So this leads to us aiming to post the request for construction bids in October, after coming back to the board for approval to post that RFP. Next slide, please. So this slide you've seen a few times before, which is updated design schedule. So the items ingredient completed, those in orange are currently in play. And the final task there will begin once post request for the bids on the construction contract. So as you remember, we're holding the design consultant type schedule because we're overspending on O&M each month to keep the system operating in this condition. So the benefits to the district to rehabilitate the system as quickly as possible. So we had a very aggressive schedule for the design consultant. As we're coming to the end of the design phase, I thought I'd just show our progress on it. So the light green boxes here show the schedule slippage we've seen over the design phase. As you can see, we developed about a 6-week slip in the early days of the project. That was due to the scheduling constraints that we had between ourselves, the design team, and Veolia that delayed planned site visits for the condition assessment. The pre-procurement task here, task number 4, appears to show a significant schedule slip, but actually what happened there is that the components we're pre-procuring, the lead time significantly reduced as we went through the design phase. So it actually allowed us to have more time to develop the specs, develop the design further, and have a more cohesive IFQ to send out pre-procurement without impacting the construction schedule. Overall, the design phase has taken approximately 2 months longer than initially planned. So as I said, it was a very aggressive schedule at the beginning, so 2 months slippage is not too bad considering how aggressive the schedule was. Next month, staff aims to bring some more recommended pre-procurement awards to the board, as well as a request to post the RFP for construction in October. This would ideally lead to a recommended award for construction in the construction contract in January of next year, which aligns with the preliminary construction schedule we received 90%. Next slide, please. So this is the overall project schedule. Again, mostly covered here with changes in red. The diamonds here represent board presentations, boxes represent staff actions. So as I mentioned, over the next couple of months, we'll be returning to the board with pre-procurement recommendations. The aim is to award the construction contract in January of next year, which would ideally lead to an estimated project completion. Sorry, the board package symbol there, but it's that would be in August of 2026 is the currently scheduled project completion. Next slide, please. So this is a slide, again, we've seen a few times before, but we do update it every time we present this. So it depicts the net present value of both the do nothing option A and the proposed refurbishment option B over a period of 15 years. Table to the right here shows the anticipated savings for undertaking a refurbishment. As you can see, the initial capital expenditure of the project over the next 2 years is offset by O&M savings for each passing year. And that's both during the second year of construction and upon its completion, because we'll be taking the prices offline for the second year of. Our calculations show that this refurbishment will save approximately $3.6 million each year in O&M savings, so that's $300,000 a month approximately. And it's anticipated that the break-even point will occur at some time in either late 2028 or early 2029, with these savings leading to a net positive after that. So as I mentioned, we're anticipating the 100% design submittal in late September or early October. There are minimal design modifications required from the 90% design we've identified. And so we don't anticipate any major changes between the current design submittal we've received and the 100% design next month or early October. Our aim is to return to the board next month to request approval to post that RFP for construction. And the aim is that if we get that RFP posted in late October, once we've reviewed the 100% design and ensured it's ready to go out as bid documents. We'll be looking to do a minimum of a 2-month procurement process. And then this would lead to bids coming in late December and then a recommended award to the board in January 2025. The engineer's estimate for this construction contract, as of the 90% design submittal cost estimate, is $14,692,024, including contingency. The 90% estimate was a Class 2 estimate, as per the Association of the Advancement of Cost Engineering, or AACE. So this means the estimate is considered to have an accuracy of -15% or +20%. So we can anticipate the construction contract cost to fall between $12.5 million and $17.6 million, including contingency. As I mentioned, we don't anticipate any major design changes between now and the 100% submittal, so we can expect that engineer's estimate to stay approximately the same when we go out for bid in a couple of months. If we award the contract in January 2025, we anticipate the notice to proceed to the contractor in early March. And as I mentioned, that would lead ideally to project completion in August 2026. So for the item we're actually here for today, over the next couple of months, we'll be returning regularly to recommend approval of procurement items for this project. Most of these procurements will be conducted via invitation for quotations, with some components there being sole sourced through the original equipment manufacturer for the press due to their bespoke nature. This table shows the list of pre-procurements for this project based on the estimated construction schedule and component lead times. So next month, we aim to return with the recommended procurement of those MCC electrical breakers and the rental of a temporary dewatering system. That would be a pre-rental agreement that would be activated once we actually need to bring the dewatering system on site, likely around June or July next year. The IFQs for these two, the electrical breakers and the temporary dewatering system, have already been posted, and we can expect the responses within the next couple of weeks in time for the committee next month. Later this year, we'll come to the committee with the sole source procurement recommendations and the rental of a temporary odour control system to reduce the impact to our neighbours of the odour issues we'll likely face during the project. So unlike with other West Basin projects, none of these procurement contracts will be passed on to the contract. The rented systems will stay under contract with West Basin and will be operated by our contract operators. And the procured components will be delivered to the construction contractor for installation, and the construction contractor will take ownership of the equipment as it's offloaded after delivery. The purpose of all of these pre-procurements is to expedite the project schedule. As I mentioned, there's significant savings we could be making if we expedite this rehabilitation. And the aim is to pre-purchase the low risk but high lead time items before the contractor is onboarded. So the sludge conditioning tanks we're bringing before you today, for example, they are the first part of the first stage of the construction, the installation of those two sludge conditioning tanks, first element, the critical path. And so therefore waiting for the contractor to procure them after they're onboarded would delay the project while they waited for those tanks to be manufactured and delivered. Additionally, with those tanks, we're essentially copying the design of two existing sludge conditioning tanks that were installed in 2013. And so the risk of procuring the wrong items or having an incorrect design that doesn't work with the site is minimal, because we're quite literally copying the specs and design of the previous one and updating it to meet current codes and regulations. For these tanks, it makes sense then to procure them early and deliver them to the contractor when they need to be installed. That way, we not only eliminate risk of delays, but also save the significant overhead and profit margins that the contractor would have charged us. Next slide, please. So we are today recommending the procurement of the two sludge handling steel tanks. These tanks will replace existing tanks from 1995 that are used to mix lime into the solid sludge for pH regulation. They'll be placed on the existing concrete pads, with all current piping connections being reused to reduce cost. We are replacing all of the electrical components, level switches, pH sensors, and so on associated with them. They'll be replaced and rewired back to power and control source. They're well beyond their useful life, and the risk of chasing down electrical faults through old wiring could present a significant risk to the project schedule and budget, so it's better to just replace them early. The engineer's estimate for these tanks was $416,100, including estimated taxes and shipping. Staff posted the invitation for quotations on July 15th and received 3 bids on August 8th. Public Procurement Code requires the selection of the lowest responsive bidder, which was Arnaz Engineering Contractors Incorporated, who submitted a bid of $327,985, including estimated taxes and shipping. This bid includes the use of US steel, and it has a lead time of 8 to 12 weeks. Next slide, please. As this is also a slide we've seen before, it depicts the anticipated expenditure on this project each fiscal year. So this fiscal year, we have $14.6 million in the approved CIP budget. This accounts for most of the construction costs, as well as the associated construction management, engineering services during construction, and design engineering. In addition, the bulk of the pre-procurement costs will be realized this fiscal year, mostly due to a lot of that pre-procurement, the items arriving in the first half of construction. This project is due to finish at the end of fiscal year 2025-2026, with the construction tailing off and the temporary dewatering system being decommissioned. Therefore, we see the anticipated expenditure drop significantly. In total, we anticipate this refurbishment project to total approximately $19,570,000 over the 4 fiscal years since we originally presented this option. We have secured and received $2,640,000 in refinery funding based on our prior agreements. And so the total West Basin funded expenditure comes to $16,930,000 in total. However, we do believe further funding can be secured to further reduce this West Basin expenditure, as shown on the next slide. So, as I mentioned, this slide shows total funding we've received from our refinery customers under our current agreements made in 2016 and 2021, respectively. As you can see, the project budget has significantly increased since these agreements were made, particularly the Chevron boilerplate agreement in 2016. The total project cost, including the $810,000 spent prior to this refurbishment option being selected, comes to $20,380,000, which is almost double the $11.5 million we believe the project cost in the 2016 agreement. As I'm sure you're well aware, updated agreement negotiations are currently ongoing with our refinery customers, and these new agreements will doubtless include updated project budgets, project values, but we also anticipate that allocation percentages changing, so it's difficult to assess exactly how much additional funding we can receive. Next slide, please. And so that brings me to the recommendation for you today. Staff recommends that the board authorize the general manager to procure 2 sludge handling welded steel tanks for Arnaz Engineering Contractors Incorporated for a total of $298,000 with a 10% contingency, $29,800 for a total not to exceed amount of $357,800 plus taxes and shipping costs. And with that, my presentation is finished. I have to answer any questions.
Thank you very much. Director Williams, do you have any questions?
Well, just a question to the general manager. Are you happy with this?
Director Williams, this project, again, we've been tracking the progress on it for some time now. John Venner has done an excellent job of leading this effort under the executive manager of engineering operations. I'm very pleased with this recommendation and stand by the recommendation.
Very good. I would support the staff's recommendation.
Okay. Hear from the rest of the director. Director Deere, do you have any questions?
No.
Director Gray, do you have any questions?
No, thank you.
I have one short question. What was the estimate before the bids came in?
The estimate was, that was 416, I believe, yeah, $416,100. That includes the estimated taxes and shipping
So they came in,
of $90,000.
no, thank you, congratulations on that. I think I've expressed my, opinion about doing this in the past, but we'll move this, item forward. We will move this item forward.
Okay.
Okay, so moving on to the next item on our agenda, which is approval of the agreement between West Basin Municipal Water District Conservation Reclamation Authority for recycled water system for the district and South Bay project. Mr. General Manager, please introduce that item.
Yes, Mr. Chairman, this item does begin on packet page 25. Before I introduce this item, I would like to remind our members of the committee and board that we recently had a member of our staff, Mr. Joel Blair, leave and depart West Basin Municipal Water District for a new opportunity at the Water Replenishment District. We're very excited for this opportunity as Joel very much deserves that. And with that in mind, I do want to introduce this item and let you know that Mr. Orlando Rodriguez will be presenting this item. He is currently serving as our acting engineer supervisor, and that began earlier this week. So I'm going to hand this over to Orlando and say thank you for accepting this responsibility and presenting this item.
Thank you, Jay. Good afternoon, Chairman Alvarez and members of the board. As you did mention, you can find a copy of the staff report on page 25 of the agenda packet. But also, you can also find a copy or at least an exhibit of the site itself on page 28 of the agenda packet. And that, please. Page 28. First and foremost, I'd like to start with a little bit of history of this site itself. Back in 2006, the city of Carson approved a site-specific plan for the Carson Marketplace project, which is located at a previous landfill site, as you can see there, south of Del Amo on the 405 freeway, east of Main Street, and north of the Dominguez Channel. And shortly thereafter, they began development of the site itself. The developer in 2010 designed and constructed about 950 feet of 6-inch PVC, a pipeline for recycled water. And it was understood and agreed upon that West Basin would take ownership of that pipeline upon completion of the project itself. But unfortunately, the project gets halted and ownership was not transferred to West Basin. And in 2015, the Carson Reclamation Authority was formed and they took over the site itself. And then since then, West Basin and the Carson Reclamation Authority, the CRA, has had discussions back and forth about the development of the site in terms of recycled water. They onboarded a developer that took on the site itself, the construction of a public street, which is Bernardo Street, shown there. And that's what the recycled water pipeline will follow as public right of way, along with the development of the other parcels themselves around the site. The project includes residential, commercial, some light industrial with a lot of open green spaces and a park. The goal of the recycled water pipeline is that the developer will extend that. They'll connect to the existing pipeline just east of Main Street where that 950 linear feet end. It will extend at about 4,050 linear feet going kind of east and southeast to the end of the site itself. We're estimating approximately 40 acre feet a year of demand of recycled water, which will be used to irrigate all those landscape areas that they're proposing along the development. In the agreement at Finley today, the CRA shall fully reimburse West Basin for all staff, consultant, and third-party construction inspector costs incurred by West Basin for design review and inspection services. And the preliminary cost of these services is estimated to be $58,393. Upon completion of the project and acceptance by West Basin, West Basin will take ownership not only of the newly installed 4,050 feet of pipeline that will be new, but also pending a condition assessment of the 950 linear feet. We will take ownership of that as well upon completion of the project. So with that, I would like to read the recommendation that the board authorize the general manager to execute agreement W3148 with the Carson Reclamation Authority for the District at South Bay project. With that, I would be happy to answer any questions.
Okay. Director Williams, do you have any questions?
No questions.
Director Muir?
No.
Director Gray?
No
Uh,
question.
I don't have any questions either. I would just say, and this is coming up, we don't need to make a decision now, but we don't own the pipeline now. I don't understand why we want to own another asset to maintain. Unless they're gonna pay us for the maintenance of that pipeline. So
Well, there is a 12-month warranty period once we accept it, but yeah.
once we take it over, we're
Yeah.
stuck for 30, 40, 50, 60, 100 years, whatever. So we might want to think about that. Okay, so we'll decide. Next up is the information calendar, and I haven't taken anything of sequence. And the monthly operations report first.
Yes, Mr. Chairman, this item, as you mentioned, item 6B begins on, I believe it's packet page 85. For this presentation, we do have Barca Masurlian, our Executive Manager of Engineering and Operations, leading us off, along with Susanna Lee, our Operations Supervisor, Jamie Malpete, our Water Quality and Environmental Compliance Supervisor, Frank Fuchs, our Operations Supervisor, as well as Eric Owens, our Assistant General Manager. And is that packet page 121 or 85?
Presentation.
85. Take it away, Barca.
Thanks, EJ. Good afternoon, board members. As we just mentioned, this staff report starts on packet page 85. Just a quick update on some of the operational issues. This weekend, we had a sodium hypochlorite pipeline leak in a vault underneath one of our filter basins, and we did kudos to the operations team and our contract operator for responding and making the repairs. They were able to maintain system residual and avoided disruption to production. That was a successful repair. Quick note on mid-July, Hyperion had some issues with their solids handling system, so we did receive some adverse of water quality coming into our plant around mid-July, but that got resolved towards the end of July. Eric Owens, our Assistant General Manager, and Jamie Malpete, Compliance Supervisor, will later in the presentation talk more about the water quality that West Basin is receiving. Our distribution team has responded to several pipeline leaks in our distribution system. So Frank Fuchs will talk a little bit more about that later in the presentation. Good news on the production side of things. You'll see from the slides that Suzanne is going to present that barrier production last month was around 6.8 million gallons per day on average. As of last Monday, we worked that up to 10 million gallons per day. I'll talk more about that. But we'll start off the presentation with packet page 91, a look ahead into the September E&O committee. We don't anticipate any action items coming in from the operations department, but a heads up about a ratification staff report for a critical repair that was led by our contract operator Veolia at the JMM plant on a pipeline, a microfiltration effluent pipeline at the JMM system. So that's coming up on Monday. With that heads up, I'll hand it over to our operations supervisor, Susanna Lee, to talk more about production.
Thank you. Good afternoon, directors. I need to turn to page 9. Okay, so we gave us the production number for July. As you can see, a little bit the budgets on the production. The next slide will show you. This is mainly driven by the barrier. Like Kev mentioned that we were at 6 MGD. Overall, this year we budgeted for an average of 8 MGD. So we will be catching up in the coming months. So let me look at the next slide. Again, as I mentioned, you can see from the numbers, page 94, that the main driver for the below budget is the barrier, 89% below what we budgeted. For Torrance, they had a little bit of turnaround on some of the tanks that we had lower productions for a few days during July, which drove the numbers below budget. Overall, we're 9% compared to budget. We're looking forward for August numbers, barrier being at 10 mg. Next slide, please. This is compared to last fiscal year in July, what our production is. Pretty much on par of what we were doing last July. I think next month we will see a little bit, the purple will be above the gray line for barrier. No questions, next slide. Go over highlights on some of the maintenance activities and a lot of activity going on. Obviously, we change out some reactor lamps on UV train 2 and the line silo system have a lot of needs and a lot of the high maintenance work that did was this silo slurry tank on the mixer. But that keeps our barrier LSI within the specs, so that is a critical repair that we perform. And there's a photo that also shows the line saturated what we have. For Satellite Torrance, we doing a lot of cleanup there. And over to
Real quick question for you before we turn it over. Why was the tertiary production 15% lower than anticipated?
that is on the irrigation number on the right. More information.
Yeah, we don't really have any specific feedback in regards to customers using.
So we're just demand driven.
Demand driven.
And the reason for the barrier?
We're still waiting on, at that time, we were replacing modules. We have now 5 modules out of the 8 units being replaced with the new membranes. So at the beginning of July, we were like maybe 2 of 3 units that have the new membranes.
All right, let's go ahead and move on.
Skip to the next slide. All right. Good afternoon, Chair Alvarez and members of the committee and board. I'm going to cover some water quality slides. West Basin staff has heard the committee loud and clear that you're very interested in understanding how we monitor the influent quality that we receive from our upstream partners at LADWP and at Bureau of Sand. Here today, we're going to talk briefly about a few of these parameters and how we use them to ultimately monitor the health and performance of our treatment systems. And so what you see here on the first slide is basically just about 10 years worth of data, annual averages for influent, and this is ECL influent, total suspended solids, ammonia, nitrate, turbidity, and iron. And I'll go through each one of these as to why they're important to us and why we monitor them. In this simplistic view on the graphic, we've only shown you an annual average, which does not paint the entire picture for the quality that we deal with on a day-to-day basis, but it does show you some general trends that I think are very important to understand, particularly in the performance that we've observed in the last 5 years. And to illustrate that, I would point to everything before the year 2020, regardless of the parameter, was fairly well in line with the previous years. It was somewhat static or consistent from year to year. 2021, as you're well aware, is the year that the upset occurred at Hyperion. And of course, our average water quality deteriorated. And you see that step or that climb up in 2021. And of note, particularly on this graphic, are that there are 2 or 3 parameters that have never returned to the pre-upset conditions. And so as the very first top line is influent ammonia, that really didn't even notice a blip with the upset next door. However, with TSS, total suspended solids, and turbidity, and to a lesser extent, iron, those parameters have not recovered to pre-event conditions. And I think that's worth noting because when John presents our solids handling project and the need to move forward with that project, we are dealing today with a much higher solids load, as evidenced by these graphs, than we have been dealing with, historically over the last 20 years. The good news, though, is that you see in the graph that those values are somewhat stable since the event, but unfortunately they remain higher than they were pre-event. On the subsequent slides, if we could go to the next graph, we have chloride. This is really just to illustrate the salt load within the water quality that we get. Our total dissolved solids is over 1,000 TDS, which is quite high for an effluent. But the reason that we care about chlorides and total dissolved solids is because we utilize reverse osmosis downstream to remove those salts for our for our refinery customers, for their boiler needs, as well as for the injection into the barrier. And as you can see, the solids load there was not necessarily affected by the upset condition and has been pretty stable, if not improved, since 2015. And so that's a good thing. We go to the next slide. In these subsequent slides, we're going to give you a little bit more depth, perhaps more depth than you want on some of these parameters. Again, ammonia, this is I believe, a daily value for the last 10 years. And similar to that very first graph, it shows that the value has been fairly stable the last 10 years. But one thing I would note, though, if you notice the numbers, we are today and for the last previous 10 years, we've been at about a 40 to 50 milligram per liter ammonia load. And this is important to note because our nitrification processes for ammonia removal ahead of our refinery cooling tower sites was designed in the 90s for loads of about 20 to 25 milligram per liter. And we are about twice that 30 years later. So the other thing I would point out here is the variability in ammonia. As far as the other compared to the other parameters we're going to see in a moment, this is actually a pretty stable band of variability, and that's the good thing. So as far as ammonia is concerned, this has been higher than day one, but certainly stable in the last 10 years. And it's a reflection of many things within the upstream treatment process, not the least of which is that the quality of the secondary effluent, when you have a high ammonia, that's generally representation of a non-nitrified treatment process, which just really means it's a cruder treatment than, say, a nitrified treatment process that other wastewater treatment plants might use. For us, again, it affects our cooling tower clients, the refineries, and it can also represent the types of foulants that are going to contribute to our membrane fouling that we see in our barrier and our boiler feed applications. If we could go to the next slide. This slide is the iron or the ferric representation of what we receive at the ECL facility. You can see in the last 10 years, it's been fairly stable with periodic increases. You know, this really represents upstream at Hyperion. They have to dose ferric chloride into their system in order to try to coagulate those solids and get those solids down before they discharge. Because of the amount of solids that they deal with, they quite often have to dose a lot of iron in order to get those solids down. And then, of course, they occasionally have upset conditions as well, which I would suggest are why you see these blips. Particularly this year alone in March, you know, we did see an excursion upwards of 2 milligram per liter of iron. That's notable for our treatment processes because iron can contribute to membrane fouling, again, which is what we use in our barrier and boiler feed applications. We also dose iron downstream in our disinfected tertiary or Title 22 treatment process. And so when we add iron onto iron, our distribution system may have much higher iron concentrations than we desire. We can go on to the next slide. So when we talk about solids, and again, referencing back to John's solids handling project, we measure that by total suspended solids, which is a laboratory grab sample that happens at least daily, as well as an online turbidity meter that can measure solids in real time. They shouldn't necessarily be the same. They are two distinct parameters, but they both indicate the amount of material that is in the water that we receive from Hyperion. And you can see in this case, you know, the variability that we see, the frequent fluctuations up to upwards of 100 NTU. That's a pretty substantial turbidity for a source water to a membrane plant. Okay. Again, our disinfected tertiary system attempts to remove these solids, as well as our microfiltration membrane removes these solids. All of this material that we're removing ultimately ends up in that solids handling system that you've heard staff bring before the committee and board quite frequently. So again, the takeaway here is that just the frequency of the spikes or the peaks and the magnitude of the peaks really represent that our issue today and since the Hyperion upset in 2021 remains a heavy solid load that's being introduced into our recycled water program. Next slide. These next two slides, I really just wanted to illustrate how we use this data. Again, ammonia, I referenced this. Ammonia is removed by a biological treatment system at our satellite facilities for the purposes of cooling tower use by our refinery customers. In this graphic, you see the blue is that plant. I'm sorry, I got ahead of myself. Yeah, I'm getting ahead of myself. This is turbidity in our disinfected tertiary system. So again, this is a measure of material that's coming in from Hyperion. Our disinfected tertiary filtration system attempts to coagulate and remove this solid material before it goes out into our distribution system. And so in the blue, once again, you see the same sort of peaks and variability and volatility of turbidity in our source water. But our team does a pretty good job, and our treatment technologies do a pretty good job knocking that solid material down below the permit requirement for disinfected tertiary, which is that orange bar. And you can see our product water that ultimately makes its way into our distribution system is in green, and quite often is within the regulatory requirements, perhaps with the exception of that upset condition period at Hyperion. We can go on to the next slide. Ammonia. As I was saying previously, we use a biological treatment system at our satellite facilities to reduce that ammonia, ultimately to remove it completely down to zero is the goal, so that our refinery customers can trust this water is not going to erode their their exotic materials that they use in their cooling towers. And you can see that in blue is the ammonia. It has reduced a little bit in the last few years since that upset, but it's much more variable by the time it gets to our satellite facility influent. And the satellite facility, which you see in orange, the combined ammonia, that represents the total ammonia that gets removed, or the value of the ammonia after treatment by 4 distinct units at the Torrance refinery. And so that's the combined ammonia just represents 4 different product waters from 4 different bioforce systems. Because that does not get down to our needed conditions for our contractual obligations, we utilize chlorine, sodium hypochlorite, in order to breakpoint that and drop it to as near zero as we possibly can. And so, of course, just again with ammonia, we are treating today, 30 years later, probably twice the amount of ammonia load that this plant was originally intended for back in the 90s, and that makes it challenging to achieve the contractual obligations. But we can get there. These days, it just takes more chemical, specifically chlorine, to get us down to that contractual obligation. So just wanted to show with this graph and the previous, how we use the data, specifically how those feed water parameters affect our systems. There is a lot more to it than just these 2 examples. We're not going to go through those today. I think we can skip to the next slide. I'm going to hand it over to Jamie to talk about how some of these parameters that we monitor compare to the Hyperion outfall discharge, and what we see at ECL, how that compares to what Hyperion is discharging out to the ocean. So with that, I'll hand it over to Jamie.
Thank you, Eric. Good afternoon, directors. The next few slides are going to demonstrate what Hyperion discharges out there, effluent, out there, outfall number 2, compared to what we receive. So 2 different lines, 2 different streams. This first slide is total suspended solids. The gray line, the continuous gray line you see, that is the monthly average limit. That is for both the barrier permit as well as Hyperion's outfall and PDS permit. The difference between these 2 is when we exceed, if we exceed this in our influent, we have to report it in our annual report. If Hyperion exceeds it, then that's a violation for them. As you can see, you can kind of see that they're going up towards beginning in June, start going up pretty strictly. This will more than likely cause them to be in violation. Next slide, please. This is our turbidity. Again, this is between Hyperion's outfall versus what we receive. The limit that we do not have a limit for turbidity. We just monitor for it continuously. However, Hyperion has a weekly average limit, which is demonstrated in the gray line for at 100 milligrams per liter. Next slide, please. This next slide shows the difference for ammonia. The gray line is the quarterly average for Hyperion, monthly, reported quarterly, but it's a monthly average, or excuse me, quarterly average for them at 58 NTU. This is, as you can see, we exceed them. We're starting to exceed them in ammonia, but they're starting to level out. And that I will pass, unless there are any questions, I will pass this on to Frank.
If I
Oh,
could,
sorry.
if I could jump back in.
Yes.
Sorry, Jamie, that I just want to point out something that occurs to me is that, this difference between what Hyperion has to discharge the ocean versus what we take in. That's a common issue with recycled water facilities, especially when you have two partnerships where one operates the upstream wastewater treatment plant and another operates the downstream advanced water treatment plant. Hyperion, has to treat their 250 million gallons per day for the sole purposes of discharge the ocean, not with downstream advanced treatment in mind, right? And that's been the case, I think, for 30 years, at least 30 years since we've adopted recycled water. And so, as they are heading towards Pure Water LA, I think they're becoming more mindful of how that upstream treatment will play a role into the downstream advanced water treatment. We're obviously experiencing some challenges with the water quality that we're getting today. When I worked at West Basin previously, we also experienced challenges with feed water. And frankly, back then I thought, it can't get any worse than this. And here we are 5 years later. Water quality has, in fact, in some cases, such as turbidity and TSS, has gotten worse. But again, I think it's useful to keep in mind that the city of LA is not operating their plant with the downstream advanced treatment system owned by West Basin in mind. They are operating their plant in order to meet that discharge requirement into the ocean. And sometimes those two things are at odds with one.
And I'm sorry, next slide, please. I have one more slide to go over. This is our environmental compliance activities for July. We sampled 441 samples for a total of 5,150 samples for the year. This month, we submitted our annual stormwater reports for both ECL and Carson. We also submitted our semi-annual industrial wastewater discharge reports, report on our sewer discharges for ECL and Carson. And we also submitted our application to renew our Carson industrial wastewater discharge permit to LA County Sanitation District. And with that, I will turn that over.
Good afternoon, directors. So this is our monthly update for the recycled water distribution system. This is our distribution system activities for July. Want to report that last month we had 3 leaks in the distribution system. These were service lines, 2 in El Segundo. There were 2-inch service lines that leaked, and 1 in the city of Hermosa Beach. Also a service line, and all 3 of those were repaired with no issues by Infomark. Moving on to the next slide, please. And this is just to report that the Intuit Dome in Inglewood, the Clippers, this is the home of the Clippers, the NBA team, was connected to recycled water on July 12th. So they are now using recycled water. And we estimate that they are going to be using approximately 40 acre feet per year recycled water for this site. Next slide. And these are our potable water customer service update. I wanted to highlight 2 items for WB23A. This is the new service designed in construction for Golden State Water Company. The agreement between Golden State and West Basin was recently signed. And then the pending agreement would be between West Basin and Metropolitan Water District. So once those agreements are finalized, then we will get a updated schedule from Metropolitan Water District. So we'll keep the board updated on that schedule. And for WB8, I just wanted to mention that the city of Lomita did approve the installation of the additional 600 feet needed for the emergency temporary connection. So we'll follow up with the schedule and work on that. Next slide, please. And this is our monthly sales for potable water for July. The actual demand was 8,143 acre feet compared to the budget of 8,100 acre feet. So that's a difference of 10% greater than the amount budgeted. So, and that concludes our report. I'm happy to answer any questions.
Questions? Director Dare? No. Director Graham? I do have one comment on the portable water sales. Portable water sales are up over our budgeting, which is really, really good. In the case of Metropolitan for the month of July, the first month, water sales are 15% below budget. So, in terms of just the overall income, they're already running in the red. We're a little on the cautionary side. Good thing. Sweet. Okay, with that, it's 4 o'clock. I'm gonna need to leave. We have a choice. We can postpone the rest of these information items. Or, Director Williams, you can take over the meeting.
I think we ought to keep going. What do you?
I agree.
All right? All yours.
All right, thank you. No, I'll have to leave in.
You have a choice.
Okay, so.
Mr. Chairman, we're actually on item 6A because we took B out of order.
6A.
6A.
And this begins on packet page 65. It's an energy initiatives update. And for this presentation, we have Jason Kung, our operations analyst 2.
Thanks, TJ. Good afternoon, directors. You can join me on the presentation, which is on page 68. I wanted to give a quick overview of the memo. There's overall 3 efforts outlined in the memo. We talk a little bit about the PV solar array efforts at ECL to repair and evaluation of some demand response programs from SCE, what's available today. But most of this presentation, if not all of the presentation, will focus on just the direct access fixed price generation rate and how much we've estimated to save so far. I'm happy to bring more information on the other 2 items at a later time, but yeah, this presentation is just for that. Let's go ahead and go to the next slide, please. So overall, I wanted to kind of cover what we did before, right? We used to buy energy from Southern California Edison. Now we buy it from direct access, but there's still a portion that we pay to Southern California Edison. It's a little bit difficult to estimate how much we've saved. And so that's kind of what I wanted to talk about today before we get into the complicated math. What we would have paid Edison had we not left the program and we actually paid for our energy use. So yeah, let's go to the next slide. Generally, when you pay Southern California Edison, for every dollar, 46 cents of that goes towards generation. It's a pretty hefty chunk of it. The 37 cents goes to distribution, and then there's some for transmission, wildfire, and public purpose programs. Generation in this case would be the cost of energy sources such as solar, wind, natural gas generation that SCE owns, like hydro and natural gas plants. Distribution is for grid maintenance and new equipment, including poles and wires and substations. Transmission is for O&M of high voltage transmission lines. So we no longer pay Southern California Edison for the 46%. We buy that from somebody else, but we still pay SCE for that for the other set, the sections. Next slide, please. This is an overview of the time of use curves for the 2 seasons. It's a graphic that I pulled off their website. It's a reference to, generally how much it is depending on the time you use the energy. It does not reflect actual published rates. It could be different. Consumers on time of use plans are charged based on when they use electricity during the day with seasonal changes. We have summer on top, winter on the bottom. So we have all these different complicated categories for when you use your energy and how much it costs. And so that kind of plays into the complicatedness of the calculation. Next slide, please. So these are the actual rates from SCE that were published for June of 2024 and March of 2024. So two separate seasons. For summer, we have 3 different rates for the on-peak, mid-peak, and off-peak. And same with the winter time, we have a mid-peak, off-peak, and a super off-peak price. And so in comparison to what we were doing now, we have just one fixed rate. No matter what time we use the energy, we just pay one rate. But with SCE, there's all these different rates. And it kind of plays into how difficult it is to generate our own bill, essentially. Next slide, please. Graphically, we can see, with direct energy, we pay 8.187 cents per kilowatt hour. So it's right in between the off-peak and the on-peak time, and it's better, during on-peak and mid-peak, but maybe on the off-peak not so much, right? So the The goal for this is to figure out how much time do we spend on each section of these peaks, and that helps us generate our bill. Next slide, please. I wanted to show also what it looked like for the winter time too. So this is June on the top and March up below. The winter time is cheaper than the summer. So 8.1 cents for the mid peak, 8.2 cents for the off peak, and 4.3 cents for the super off peak. So if we're using energy on the super off peak time, it's a little bit more expensive on the direct energy side than it is compared to SCE. Next slide, please. This is a general winter load curve for ECL. We wanted to, again, model how much energy we're using during certain times of the day. This is scaled from 4,400 kilowatts to 6,000 kilowatts on the top. So we're zooming in on this just one section. You can see we spend a lot of our energy on the off-peak times. Obviously, that's when we pump out the irrigation water to our customers. But we're also, still producing water during the day. And you can see kind of that curve. Spend a little bit of time on the super off-peak, ramp up a little bit on the mid-peak. This is just for the winter time. And so averaging the last 3 years, next slide, please. We spend on the summertime about 14% on the on-peak, 6% on the mid-peak, and a majority of our time during the summer on the off-peak. And then similarly for winter, we do have a majority of our time spent on the off-peak, 47%, and then 21% on mid-peak, 33% on the super off-peak. This kind of plays into, okay, how do we compare all these different time of use rates to our just one fixed rate? And we thought, okay, the best way to do this is probably to come up with we're calling it a bundled rate. Next slide, please. The bundled rate is basically a percentage weight for each of those time of use attributed to what the SCE rate would have been. So these are not published rates from SCE. This is based on actual usage from Edward C. Little. There are some times that we do better than the bundled rate, sometimes we don't. And so on the left side, we have 2024 for summer and winter. On the right side, we have 2023 for summer and winter. You can see on the right side, the summer and winter times for 2023, our fixed rate was much lower than what SCE was charging their customers at 12.9 cents per kilowatt hour and 8.5. So at any time we used energy during these two periods, we would have saved money. And then conversely, for 2024, energy has been a little bit cheaper than it was last year. So it's 7.3 cents per kilowatt hour, and then winter time, just the season that we just passed, 6.3 cents per kilowatt hour. Next slide, please. So it really is a gamble between, we're trying to predict what energy is going to cost in the future. Sometimes it could be more, sometimes it could be less. And we just have one fixed rate to carry us through the 3 years. So this is kind of a graphical representation of the 3-year contract that we have with Direct Energy. This is just comparing generation rates, not actually, how much our bill was. The orange line is our fixed generation rate at 8.1 cents per kilowatt hour. And the blue line is the average generation rate, or the bundled rate, we're calling it, throughout that same amount of time. And next slide, please. You can see the higher peaks, these plateaus are during summer times, and that's when we save the most money. We're basically looking at the area under the curve. Anything above the orange is when we save money. Anything below is when we are paying a little bit more than we would have. The next slide, please. So we did the math and took a look at all the area under the curve, including how much it costs us to leave SCE as well. There's a cost called a power charge and difference adjustment. Basically, SCE, you pre-procure your energy with SCE, and then if you leave before you get to use your pre-procured energy, they have to sell it back to the market. If they sell it for more, then they make a little bit of money, they give it back to you. If they sell it for less, then you got to pay them. And that's the PCIA charge. So including that cost in here, which we did estimate in the initial analysis presented to the board back in March of 2022, we've approximately saved about $487,000 since entering into the program. We still have about a little bit less than a year left. It expires in next April, and so we anticipate energy to be a lot more expensive in 2025. Next slide, please. And there's a little bit of potential in 2025. California requires that a large portion of our energy is sourced from a renewable source in California, so it makes it a lot more expensive because there's less supply of solar plants or regenerative sources in California. So renewable sources in California. Next slide, please. And so there's quite a little bit of savings to go for next year. But the anticipated schedule after the 3 years is done is obviously we're gonna look into lock-in rates. You know, they update every day, almost by the minute, because it's an active market. We're looking at lock-in rates for another 36 or 48 or 60 months. You know, we're obviously gonna evaluate the optimal term for the district to save our customers as much as we can. And then propose a recommendation to the committee in February 2025 with a proposed contract start date in April 2025. So we'll see how that goes. We'll obviously keep a close eye on it, but we wanted to update the board on how much we've saved so far. Be happy to answer any questions you have.
Questions? Anyone online, question? Okay,
We're ready to move on to the next item.
yes.
Our last information item is item 6C. It's our monthly engineering update. This begins on packet page 101. And for this presentation, we have Marco Serwin, our Executive Manager of Engineering and Operations, leading us off, along with Veronica Gouvet, our Engineering Supervisor, Kevin Cullen, our Engineer 3, and John Benner, our Engineer 2.
Thank you, EJ. So as you can see from the staff report, there are a number of projects, there are another number of updates to several projects that are underway. On packet page 122, just a quick note on a couple of projects that have been completed. The Nash Street lateral project, we made a couple of presentations in the last 2 months about that project and how it's been completed. Also now completed is the Edward C. Little disinfectant tertiary product pumps and VFD rehab project. And we plan on coming back next E&O committee and give a little bit of an update on that project that have now been completed. We plan on including 2 new pending projects onto the staff report. One related to our elevator here at the DLD building and also the fire protection system rehab at the Edward C. Little. You go to packet page 126. Oh, I'm sorry, 128. At the start of the presentation, this is again just an outlook to the action item that we anticipate for next month. As John mentioned earlier in his reporting, we're looking forward to get approval for awarding contracts for 2 items related to the solids handling facility, the electrical breakers and the temporary bypass system, as well as asking for the board's approval to issue request for bids on the solids handling system.
Sorry, I didn't understand.
Next month, we plan on coming to the board and make a few requests. 2 of those requests is for items for the solids handling system, breakers, electrical breakers, as well as a temporary bypass system. And then the 3rd request would be to get the board's approval to issue a request for bids for the whole project.
Thank you.
Those are the anticipated requests. With that, I'll hand it over to our engineering supervisor, Veronica Gouvet, to give us an update on the PV lateral project.
Good afternoon, directors, members of the audience. Please follow me to page 130 of your page. This is just like what you have seen in the past for the construction anticipated schedule. However, though it's not in here, we are anticipating the construction of the pipeline project to be completed in September. As you can see later on in a slide down the PowerPoint presentation, you will see that the pipeline has been installed. It's all underground. So right now what the contractor is basically doing is just pressure testing, slurry sealing, and doing the final touches to that and completing the master meter. If you can please follow me to page 132. These are just like some pictures of the progress of the construction. So this is on the City of Palos Verdes Estates, where the contractor is installing the master meter that is going to be able to communicate to the booster pump station and Lago Seco pump and to the golf club to allow the flow to go through. Again, this is still ongoing. The next page, these are pictures of Vista, Montana. Next page, please. Yes, so these are pictures from Vista, Montana. So this was the last segment that was left to install pipeline. Once the city was completed with the fix to the slope, they did allow us to come in before they opened the road, and we were able to install the pipeline. So with that in mind, all this entire segment of Vista, Montana has now been installed, and all pipeline has been now fully put in the ground. You can follow me to the next page, page 134. This is just an overall view of how much pipeline has been installed. You can see now everything is in yellow, which means all that line is in. And the only work that is remaining that we're still working on is the master meter, and the other activities that are completing the contractor is basically the pressure testing, the pavements, Louis seal, striping, and miscellaneous punch list items that are more like aesthetics. To the next slide, please.
Before you go to the next slide,
Yes.
speaking of that area, is any of our property endangered because of the movements that are going on now in the Torrance area?
Not that I'm aware of. Yeah, no, not that I'm aware of. I believe that what is happening in the city of Palos Verdes Estates, it's on the other side of the peninsula, but
Western side.
we are not in that area.
Thank you.
Next slide, for the pipeline. So we have the Solis Group, who is one of our consultants, helping us on making sure that we monitor our contractors' activity to comply to the labor compliance for the PLA, and as well as with the grants that we have. And basically, our percent local goals are being met. Tier 1 percentage to be met is like 3%, and we are meeting it. The tier 1 is at 18.9%, and local is 12.2 at tier 2. So those two combined basically make up for that 30% on a meeting goal of the tier 1 local usage. At risk, we're meeting our percentage at 5.1, and the apprentices is at 31%. The next slide, it's just again summary of hours by local residents on the tiers by division. Next slide, please. Page 137. So this slide will be updated. We are starting the construction of the pump station next Monday. Our community outreach has already gone to the community and start basically advertising or like the more information regarding the starting of the construction and what to expect. So that's already in motion. Contractor is putting the no parking signs tomorrow. It's a 72-hour advance signage that needs to be installed, and the contractor will be moving to the site to start with the first phase, which is the installation of some parking spaces that we're going to be removing with the pump station. So that was one of the conditions that the city had given us, like to install those parking spaces before we remove the next ones. So this is like will be updated next month. So you can follow me to the next page, page 138. Again, this is just like progress on the pump station construction. Again, our invoices, because we haven't done much on the construction, there's only limitations to the mobilization. And there was another invoice that is in the process of being approved, but this board memo was submitted several weeks ago, so that information didn't make it to this item. To the next slide. So this is just a summary of the budget. And if there's no more questions, that concludes my presentation.
Thank you. Questions? Staff? None?
Next.
Anyone online? Nope. Go ahead.
No, thank you.
Next up is Kevin.
Thank you, Barto. Good afternoon, directors. I'll provide a brief update today on our
JMM CRWRP Phase 2 expansion project, starting on page 141. Highlight some recent activities. I guess before I dive into these, I'll just provide a quick update. Last month, we reported some challenges that we were working through in regards to the integration of the controls of equipment from the local PLCs to the DCS. The issues we encountered were concerning a latency issue, which was a delay in the communications. Happy to report that we have since resolved that and are back on track and inching towards completion again. Recent activities, we completed CIP cleanings on the membranes, continuing to maintain the integrity of the system. Next slide, please. We also followed up with the contractor for them to complete remaining punch list and observation work. So here's just one example. They had a bunch of cleanup work of their wiring, conduit labeling, and cleanup of duct bank penetration. So you can see before and after photos there. Next slide, please. On the left-hand side is the device which solved our latency issue. This was a suggestion that we suggested to the contractor early on in the project. They did not follow our recommendation, but have since installed it, and it did help significantly with the latency issue. So glad that we're back on track. Next slide, please. Here's an overview of our commissioning status. We've completed the first 4 phases. The final step for us to get to final completion is the 30-day acceptance test. Currently, we are going through loop checks. So the contractor is in their final week and a half here of their internal checks. We will then perform a witness of those checks and some functional testing. Following that, we will enter the 30-day acceptance test. So key dates that we're looking towards are starting the witness loop checks on September 2nd and starting the 30-day test where we'll be solely producing microfiltration filtrate water through the CEMF starting on September 16th. So that's a big date for us. Next slide, please. Here's an overview of the remaining activities. Up top, you have what's required for the 30-day acceptance test, most notably the loop check process, and then a list of the other outstanding items, mostly administrative, for final completion that we will require of the contractor before we issue that notice of completion. So that concludes my update, and I'd be happy to take any questions.
Okay, thank you. Questions?
Project updates. John will lead. DCS.
Yeah, good afternoon again, directors. So just a couple of slides here on DCS update. So as you remember, we approved, the board approved the award to Orcadis for the owner's advisor on the DCS design build project refurbishment last month. So we've got the kickoff for that at the end of this month. So we'll be onboarding them soon and we'll move on with the actual work. Regarding the procurement of the design builder, which I hope will take place, the procurement process later this year. We're obviously still undertaking outreach. We're meeting with many different consultants and companies that will be interested in that project. The procurement documentation, due to the nature of the progressive design build being so different to the normal project we do, we've had to rewrite our procurement documentation from scratch. So I'm pleased to say that our RFP, our request for the proposals template, is now completed, ready for the owner's advisor to finish off. And the contract template is also completed. So we've effectively written those two from scratch. They're at about 90% level now, ready for the owner's advisor, to finish off. Maybe taking the template to the actual active project. The scope of work development is underway, so that's a critical component of this, defining the exact scope of work for the design build team. The owner's advisor is going to be instrumental in that. That's one of their main tasks. So we're getting into about a 50% level internally, and then the owner's advisor will take that through to 100%. In total, the document package will be about a 75% level total for those 3 sets, and the owner's advisor will take those through to 100% throughout September and probably October as well. And the aim is to post that RFP at the end of this year in November. So this is just the overall schedule of the project. We've procured the owner's advisor now. We're moving into the design builder procurement at the end of this year, and that will continue through the first quarter of next year. And then we're aiming that once we bring the design build team on board, we're hoping by around fall of 2025 to finish that pre-construction phase. and have that guaranteed maximum price. We're negotiating that guaranteed maximum price and then move into the construction phase towards the end of 2025. And hopefully by summer 2026, we'll have completed construction and have that new DCS system installed. Yeah, that concludes my update.
Questions? Move on.
Very much. That concludes the report and concludes all of our information calendar. Item 7 on the agenda today is the closed session. We have no closed session items today, which brings us to director's comments and future agenda items.
Okay, directors.
Look, we're making progress.
Right, very good. All right, well, I'm not supposed to be here. I'm in San Diego. So
That's right, man.
so anyway, well, we will.
Director Gray. Hello.
Director Gray. There you
Want to
are.
make sure you guys know I'm still on the line, and thank you to staff for all the reports today. Thank you, Mr. Chair.
Thank you for that. All right. Anything else? We are adjourned. We will meet again September
18.
18th.